All right, so we're reviewing linear search here. There's a good little summary here. Let's get our code going. So first thing I'm going to do, as always, I want to fork to my personal repository. I'm going to click fork, go to encore.r/cp. Takes a couple seconds. All right, there we go. So I'm going to drop down my code button here, copy the URL, then go over to my terminal, which I usually have open here, and do git clone, get that URL. Okay, cd into that folder, so that's linear search, and then do a code. So code period, again, is going to open this folder in a Visual Studio. All right, so we have JavaScript and we have Python. So let's do this in Python since that's what yesterday's topic was about. So the first thing is I'm going to look at the spec file and see what test cases there are. So linear search is looking for 3. It should find it at index 2. Linear search is looking for a value of 4, which doesn't exist. So we expect none. Likewise for 13. Okay, so we could add more tests here. Let's kind of add a few more, make this a little more robust. So let's add maybe, let's see, a string. Now this should return none because the string value is not the same as numeric value. So make sure we're using like triple equals instead of double equals. I guess, sorry, this is Python, so that will fail anyway. What else? We could search for 1. And that should find it at index 3. All right, so a couple more tests to make it a little more exciting. Let's look at the README just to make sure you know what we're doing. So release 0 is basic linear search. Write a function linear search that takes 2 arguments, the object, string, or number you're searching for, and the array you're searching in. You will also want to add some driver code, okay? All right, so again, we're just writing a fairly simple search algorithm in linear search. Let's start going. All right, so we have a value to find and an array to search through. The direction said we can only use a for or while loop. We can't use any other shortcuts in Python. So let's go for that. So I'm going to start with, let's quickly pseudocode this. So search through array if we find our value, return the index. If we don't find our value, return none. All right, pretty simple pseudocode there. There's not too much going on here, but let's code this up. All right, so I'm going to write a for loop or a while loop. Let's go with a while loop. So I'm going to do I equals 0 while I is less than the length of my array. All right, so basically I want to go through my entire array. The reason I chose a while loop is because I want to keep track of the index. And according to the rules here, I can't use enumerate. Or I guess I can't use enumerable, but enumerate might be the same. So a while loop, and then we're going to check our values. So we're going to see if the array search through the value at that index is equal to the value to find. If so, we want to return our index. If not, we're just going to continue this loop, but we need to increment our I value. So I'll do I plus equals 1. All right, so basically it's essentially a for loop, but can track my index here. Again, we can write it as a for loop if we use enumerate. So just to kind of highlight that, I'm not sure. Let's see. All right, I'll just keep it as a while loop. We could probably do it as a for loop as well. So we did that, and then we find our value, return the index. We're doing that here. And then if we don't find the value, we want to return none. Okay, so I think that's the general gist. We should definitely run our spec file, make sure these test cases pass. So let's quickly run our spec file. And we'll do our cd into our Python directory, and then do Python linear search spec. All right, we got all true. So initially, that seems promising. Probably want to add more test cases. These aren't too elaborate. We do also have this test array to search through in case we want to search through 1,000 entries. Just more values we could have there. What else do we want to do here? Yeah, I guess we'd add a few more test cases just to verify. So let's add some edge cases. So let's see if we find it at the first value. That should return 0. What's another edge case? I guess theoretically, again, we could have duplicate values. It should return, for the first instance. So in this case, if I have duplicate 3s, it should return the first 3. So that'd be at index 1. What else can we have? We could have more like off cases where we have different types.
You test the last value also.
Yep, definitely worthwhile. So let's make this 99. And that will be the last index. So that is what? 2, 3, 4, 5, 6, 6. All right, I think that should be good enough for test. Maybe one more for a different type. So we do 99.9. That should obviously not find it. 0.1 even. All right, let's give that a quick spin. Verify. All right, we got trues there. So it seems like linear search, I think, is looking good here. So again, we created our simple pseudocode and then coded in our solution after that. I decided to use a while loop just so I could keep track of my index value easily. Again, we could do that with for loop if we did something like for ix in enumerate. So enumerate will return an index value and the value that we care about. So that's another way we could do it. But I'm not sure if the rules say we can or cannot use that. So I went with while loop. All right, that takes care of linear search, which was release 0. So let's do a quick commit. So I'm going to clear my console, do a git add everything, git commits that message completed release 0 in Python. Okay, and I'm not going to push right now because I still have more work to do. I could push again if I want to save this to the cloud in case I lose my work here. I totally could do that, but I'm going to continue developing before I push up to my GitHub. So let's go to our README and look at release 1. All right, so we have global linear search. Write a new function, global linear search, that returns an array of all indices for the object it searches for. Yep, so we had a test case for our basic linear search right here where we had a duplicate. So we had this 3 that occurred twice, but we only returned the first index. Global should return all matches. So in this case, if this were global linear search, we should return index 1 and index 6, it looks like. All right, so that's the difference for our new function. Here's an example. So for an A in bananas, it's going to return multiple items. Sorry, before I proceed, was there any question on release 0? I want to make sure we're not going too fast. All right, good. Hopefully everyone's good with linear search. Let's do the global linear search. So what needs to be different here? Well, we need to not simply return when we find our first item. So I'm going to create a new function as I requested. Call it global linear search. It's going to take in the same values, but instead of returning just one index, it's going to return a list of indices. And that list might only have one index in it, but it's still going to be a list. So let's create a list. Found index list, a long name, it's going to be empty list. And I know at the very end of this, I'm going to return my found index list. Now, I'm not sure what the requirements say about if you don't find it, should you still return none or still return empty list? Since I feel like it's not specified here, I'm going to return empty list, but we could definitely change that if the requirements change. So in this case, if I don't find anything, I'm just going to return empty list anyway. Okay, so let's write something similar. I'm actually going to copy what I had before because I know my algorithm is going to be pretty similar. So I have my while loop. In this case, I don't want to return. I want to store the index. So I will add it to my list. I'm going to do found index list append the I value. Okay, so that I believe will achieve it, my solution, but again, that's just a guess. I should definitely write some test cases, make sure I get what I should expect. So let's add more test cases for the global case. So these are going to be linear search and global linear search. All right, so for our first test case, we need to import this. So global linear search. So in Python, we don't have to write the export module that like we do in JavaScript. We just declare functions and import them as we wish. So global linear search is the function I created. I'm not sure why that's complaining, but we'll ignore it. Okay, so for our simple case, I guess where we have 3 elements, only 1 instance of it, we should get a single item back in a list. But again, the difference is global will return a list versus linear returns the actual index instead of a list of indices. All right, so that's one test case. Let's create another one. Let's use the one that they gave us just to make sure that one works. So we have bananas. And then we're looking for value A. And so I believe that'd be at 1, 3, and 5, right? Because index 1, index 3, index 5. Let's do a couple more test cases here. So what else can we add here? Okay, so we want to test, we have multiple values, so let's give that a go. Let's do a 4, a 17, a 3, 8, a 3, a 3, a 3, and a 1, and a 99. All right, so we have a bunch of 3s. That should return index 2, index 5, 7, 8, 9. So if I remember that, 2, what was it? 5, 7, 8, 9.
8, 9.
All right, so again, hopefully my expectations are correct here. If so, then hopefully that should be equal. All right, let's run these 3 and make sure that global linear search looks good. So I'm going to actually comment these out temporarily and clear my console. And let's give this a run. Okay, got some trues. That looks promising. So you probably want to add more test cases. Again, 3, not the most elaborate test case I've written here. So maybe I can mix and match. Do something like let's say I'm looking for value 1. Might have 1 here.
What about doing one with just the empty list?
Yep, great suggestion. Definitely want to test all those edge cases. Thank you, Kyle. All right, so in this case, there should be 2, 3, 4, 5, 6, 6, 2 and 6. Love the suggestion. I totally should remember to do that. So I want to test the case where we don't find anything. So let's say we're looking for a value of 5, which doesn't exist. That should be an empty list. Yeah, again, I'm not sure what else to test here.
An empty source list.
Great suggestion. Love that. So you guys are good at coming up with test cases. So, empty list here. This should return empty list because there's nothing to search through. Definitely good. Make sure our logic is sound and handle empty list. Okay, I like those test cases. Let's just run those, see if those are good. All right, we got a bunch of trues. So, I think these are good test cases. I'm pretty good with this. So that takes care of global linear search. So let me do a quick add. So I'm going to do clear my console, do git add, git commits, completed release 1 in Python. Okay, I'm not going to push up to my GitHub quite yet. There's one more thing I want to do here. So let's uncomment linear search. And this is kind of going to lead us into our lecture today of test-driven development. So we're in some test cases, and they all pass for both, I guess, global search and linear search. But what if I want to do some refactoring, but I still want to preserve the existing functionality? That's where, I'm going to look at my code here. Looking at this, I see kind of some duplication here. Like this logic is very similar, right? Like we're doing a while loop, we're checking if the value exists, and then we're doing something with the index. Maybe not the same exact thing, but in this case, I might want to refactor. I'm not saying necessarily refactoring would be the best solution, but definitely some redundant logic here. So it's something I want to try to see if I can cut down here. So I'm actually going to create a third function here. Let's call this linear search helper. And then what this function is going to do is going to try to combine as much of this logic as possible. And then each function can call this new function so that we have, we reduce our redundancy and centralize our logic. So I'm going to copy what we had here, add this to my new function. Probably need all these values. My new function will take in something very similar. But I'm going to add a new parameter. It's going to be called only one. So only one will be a Boolean. And if I pass in that is true, it's going to only look for the first instance. If not, it's going to look for all instances. So maybe I can name that find all. Find one or all. Not sure how to name this. One or all. All right, so if this is true, it'll be find one. If not, the false case means or all. So I usually name my Booleans, not always, but usually have them or, so it's clear what the true case is and what the false case represents. All right, so I have this new Boolean, so let's take advantage of this. So if we find our value, want to store it in our list, I think we still want to do that. But in this case, we're going to check our Boolean. If find one or all equals true, let's return index list. Otherwise, we're going to continue this loop and then return our entire list at the end. One note about writing, if statement like this, I could omit this if I know for sure that's going to be a Boolean. Like if this Boolean is true, I don't need to compare it to true. Like the true just takes care of itself in that case. So since I know I'm going to pass in a Boolean, I'll just leave that off. So if find one or all, meaning if find one is true, then I want to just return the list after I find the very first index. So let's add a comment to make sure that's clear. So if we only need to find one, return after our first. All right, so we're going to return in that special case. Otherwise, we'll continue on with our while loop. Okay, now that I have this helper method, I can.
Hey, Ankur, a quick question. Is there a reason you're returning an array when you're only searching for one thing instead of just the specific index of the array?
Yep, great question. So the reason I chose to return an array is because I know I have two different criteria, linear search and global linear search, but I want to use this helper function for both. Since global linear search requires an array, I kept that array around. And we'll see why I went with that, because if I didn't keep that array around, this function here wouldn't be able to return multiple values necessarily.
Right, but I'm talking in the specific case where I guess find one is the case where you're going to have find one as true.
I see.
And you're going to return to linear search instead of just returning array to search through sub I.
That's a great question. So that gets more into design, and I think you can make an argument for both. The reason I'm returning a list here is because typically speaking, from a function, I would expect the same return value type, regardless of which special condition it hit. So in this case, I would always want this function to return an array, or sorry, a list, because I want that to be consistent. I would say it's generally bad practice if your function returns different data types when it doesn't need to. So I just want to keep that consistent. But I'm glad you asked that question. Definitely could just return the value here. And then I would know that whenever I pass in find1, this function will return the actual index instead of a list of index. So yeah, again, it could be up to your discretion, whatever you feel is best.
But in general, it's a best practice to always return the same type of data from a function.
Yeah, I would say just to have that consistency, as in the caller of your function should be able to reliably expect a certain data type back. Otherwise, your caller would have to like conditionally check it if if it's a list or a specific value, because then we'll talk about that a little bit further. But great question. I think that's a wonderful question to ask. Okay, so in this case, I'm choosing to return a list in both cases. So let's use our helper function for global. So I'm just going to do return linear search helper. And one thing that we brought up yesterday, let's actually just go ahead. So linear search helper, pass in the values. Right, search through. And in this case, find one or all. That's going to be false because we want to find all. So we're going to pass in false for that case. And then for the linear search case, we want to, let's return a list. Okay, so another reason why I feel like returning a list would make sense is because in the case where we don't find something, so if this never got hit, but we only want to find none, we return an empty list in this case. So that'd be, again, a little inconsistent if we find a value and we return like an index versus returning an empty list. Again, our caller would have to check, okay, do we get a list back or do we get a value back, and kind of do that a little differently. I mean, it's not going to be too much of a headache, but again, another reason why I would prefer just to return the same data type and handle that. So in this case, we're checking if not empty list, sorry. So let's say not equal to empty list. All right, so maybe another way I could do this would be length. So length of the list, if that's greater than 0, return the first index from it. Otherwise, if that list is empty, we know that's the none case. So linear search returns none if it doesn't find it, versus global search, I decided to return empty list. Again, the requirements didn't specify unless I skip over that. But for global linear search, I'm returning an empty list. All right, so now that I've made refactor changes, hopefully none of my functionality changed. So this is why my test cases still exist, and that's why testing is really important. So we'll talk about that more in detail, but I still have my test cases, so all of these should pass, even though I've made some refactoring changes here. And since we do have test cases, we could verify if I broke any functionality or if my functionality remained the same despite all the changes I've made. Let's do a Python linear search spec. Of course, I get an error because linear search.
You're in the wrong folder.
Ah, good catch. So I want to cd into Python folder. Python linear search spec. Okay, we got a whole bunch of trues. Looks like we're passing all our test cases. So again, that's just highlighting why testing is important, and that's the topic of today, is when you make changes, your test will verify if you actually broke anything, because it's really easy to break something. Again, hypothetically, let's say I didn't handle this case correctly. Like let's say I just decided to return index 0. This will actually return error, but let's say I had a try catch here. So let's just run this. I guess our test cases won't quite run because we get an error. But what if we had a try catch except? So we talked about try except a bit yesterday. We'll talk more about it tomorrow, but this is just so my application won't crash, and let's just do nothing here. So this pass statement, I'm not sure if I mentioned it yesterday. You can write this pass keyword, which basically gives this block defines this block with no functionality. If you leave this pass off and I just want this to be blank, you're gonna get an error because it's gonna expect something down here. So pass just means you want nothing to happen for that code block. So now this will try to run, but if this throws an exception, we'll do nothing, but the application will continue to run. So if I do it this way, okay, that's not what I expected. Why not? I guess my function by default returns none. So how do I fix this? Let's just return -1. All right, so in this case, if there's an error, I'm gonna return -1, but my application will continue. All right, so now we got some false cases here. So again, I messed up something in my logic because I refactored. My test cases are telling me, okay, you messed something up, check those test cases. So it looks like I'm failing, where I return none. So I'm like, okay, there's something wrong here. What's the error? Okay, -1's not correct here. I need this to be none. And not the most best example, but hopefully that's clear why test cases are good to have. Because any changes you make after the fact should still maintain your functionality. Okay, so I think that takes care of linear search. Let's commit that. Git commit -m refactored my Python code. All right, and then git push origin. So I'm finally gonna push it up to my GitHub. And there's no issues there. Then I'm gonna go to my GitHub. So let's navigate there quickly. Oh, sorry, I was already there. All right, so if I refresh here, my Python timestamps are updated. So, I can verify that my code looks like what I added. That looks good. So I'm going to submit a quick pull request for the Python portion, even though I don't have a JavaScript portion done. I just want to do a pull request now. A new pull request, create pull request, give it a title. So offers Python solution to create pull request.
Ankur, quick question. So do you have to do a second pull request if you already did the JavaScript portion?
You do not. So I did not do the JavaScript pull request. So if you submit this project houses both the JavaScript and Python folders. So you only do one pull request, and then any other changes you commit to your personal GitHub will be reflected in that pull request. So good question there. You don't have to make multiple pull requests for the same challenge. Okay, so that takes care of linear search. Were there any other desires to go over any of these challenges? Kind of leave it as an open question.
So I had a kind of specific question for the factorial. So I did both of them in JavaScript and Python didn't have any issues. It was pretty easy to code. But then for JavaScript, I got a false for the test case in which it looked for factorial 45 because JavaScript rounded it.
Gotcha.
There's a precision difference between the answer and the thing that we run. The test, it should be testing to make sure it's within a certain precision.
Yeah. But is there any way, because I